Hey guys, I hope that I'm live right now. If you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. Hello everyone, if you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. No issues whatsoever, right guys? Everybody is able to listen me properly. Okay, great. So how are you guys? Is everybody all right? Is everybody fine? Please let me know. Is everybody all right? Is everybody fine? Please let me know, guys. No issues whatsoever, right, guys? Okay, great, guys. Awesome. So, do let me know, guys. Yesterday we were not able to learn anything, but did you guys utilize that time? I told you guys, right, that even though we are not able to have a class yesterday, did you guys utilize that time or not, guys? That is the main question right over here. Yes? Good. See, guys, even if the class wasn't there, try to utilize as much time as possible. Okay. So, what we are going to do today is that we are going to start by learning our very first algorithm today, that is the Minimax algorithm. So, that is the AI algorithm that we are going to learn in our today's class, guys. It is a very simple algorithm, it is not at all difficult. So, just make sure that you are listening to me very carefully. Okay, just make sure that you guys are able to listen to me very carefully, guys, and it will be very easy. Okay, it will be very easy right over there, guys. Just focus upon the class. It is one of the most easiest AI based algorithms out there. Okay, if you have ever played tic-tac-toe, it will be very easy for you guys to understand. Okay, will that be fine, guys? Please let me know. Will that be fine, guys? Please let me know, guys. Great, awesome. So, guys, what we'll be doing is today we'll be starting out with learning the algorithm itself. It is a very theoretical based class because from tomorrow onwards we are going to start coding the entire project. Okay, because it will take us at least 2 days to code the entire project, guys. So, what we're going to do is today we'll be understanding the algorithm in its entirety, looking at examples, figuring out that our basics are very clear right over there so that we are able to start with our project from tomorrow. Tomorrow we are going to start coding the project itself from the utmost beginnings. Okay, I'm not assuming that you guys are knowing about some particular topic or something. Everything I'll be explaining it within the class itself. So you don't have to worry about anything. And even if you are having a mobile phone as well, you don't have a laptop, you don't have a desktop, no issues in that. You will be able to make the entire project from your mobile phone. You will be able to code it, you will be able to use it, you will be able to share it with any of your friends itself from your mobile phone as well. So you don't have to worry about anything. Okay, will that be fine, guys? Please let me know. Will that be fine, guys? Please let me know. Okay, great, guys. Awesome. So shall we start the today's class, guys? Shall we start? So on 5th, my friend asked why there is no attendance. Okay, that's great. Okay, guys. So shall we start the today's class? Yes. Are you guys excited? Are you guys okay? So yes, the date went absolutely well. We enjoyed a lot as well. Thank you so much for asking that. So, are you guys excited for learning a new artificial intelligence algorithm today or not, guys? Right? Please make sure whatever I'm going to teach, I'm going to make sure that your theory is perfect. You are able to understand the concepts right over here, as well as some of the important interview questions as well related to the project. Because when you're creating a project, you will be taking up for an interview, for an internship, or for a job profile as well. So they will be asking you some important questions out there, guys. So I'll be answering some of those interview questions. So please make sure that you guys are listening to me very carefully. These will be some important interview questions as well. So let's get started with our today's class, guys. So let me just open up your chat section on my laptop so that I'm able to see what you guys are typing about. Again, in today's class as well, there will be multiple attendances that will be there. So I'll be taking up one attendance in the next few minutes. Then I'll be taking up another attendance as well, guys, somewhere in the middle of the class and then at the end of the class. So there will be multiple attendances in today's class, guys. Just keep sure that you guys are able to understand that, because don't come to me at a later point of time complaining, sir, we didn't knew that there were multiple attendances. So I'm letting you guys know right now itself that there are going to be multiple attendances in today's class. So keep that in mind when you guys are attending the class itself. Okay. So I've opened up your chat section on my mobile phone. So let's get started with that. Let me open up Paint right over here. Okay. So yes, guys, the date was absolutely great. Okay, you don't have to worry about that. Okay, so I think so. This is the computer, right? Keep it the opposite way. Okay, so let's get started. So the name of the algorithm is called as your min-max algo, also popularly called as the Minimax algo as well. Okay, both these terms are used to like denote this particular algorithm itself. Both minimax and minmax as well. Both are used, so never get confused that okay, somebody saying minimax, I have learned about minmax. They are both the same algorithm itself. Now, any game that you are having, especially tic-tac-toe. When you think about tic-tac-toe, how many players play this game at once, guys? Could you guys let me know? How many players are involved in playing this game, guys? Please let me know. Only two, right? There are just two players that are there who are going to play this game. So, player 1 and player 2. So, this min-max algorithm as well is catered to only those games where there are two players involved. Not one, not three, just two. Okay. And we name these players at the min player, okay, and the max player. We name these players as the min player, that is the minimum player, and the max player, that is the maximum player. You can denote this name to anybody. Okay, these are just the names for these players, just a denotion itself, that this is going to be called as min, this is going to be called as the max player. Okay, now the concept of the game, any game that you are playing, is basically both of the people playing the game are playing the game to win, right? You're not playing this game to make somebody else lose. You're not playing this game so that anybody else is able to win. Your aim is to make sure that you are able to win. Am I understood right over here? Your aim is to make sure that you are able to win right over there. Right, guys? Please let me know. Great. So that is the concept, that minimum player is trying to win. Maximum player is as well is trying to win right over there. Both are trying to win. Nobody is trying to lose. Nobody is trying to make anybody else win. Both of their aim is to win the game. Now, what happens inside of a game? Everybody gets chances. For example, if player 1 is getting the first chance, so he has 9 places where he can place his X, right? He can place his X here, he can place, or else he can place it here, he can place it here, he can place it here. So he has 9 places, 9 choices to make. Once player 1 is able to make a certain choice, then for example, he makes sure, okay, I'm placing my X right over here. That is the choice that player 1 is making. Now player 2 has the choice of putting his 0 on the rest of the places, right? Then he has only 8 places where he can put the 0. Right, guys? Please let me know. The player 1 has put his X at one particular position, then the player 2 has 8 probability right over there. Right, guys? So what happens is, at one particular point of that 3 end goals, like after putting x0, 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 one after the other itself, there are 3 things that can happen. First is that the player 1 wins, that is minimum wins. The second one is that player 2, that is your max, wins, or else it is a draw. Right? These are the only 3 game states that can happen at the end. Either player 1 can win, that is the minimum can win. Either player 2 can win, that is the maximum can win. Or else it can be a draw. These are the only 3 things that can happen. Let us try to map this out. Let us try to draw this entire thing out itself. Let's just assume that for our case, player 1, that is the minimum, is going to make the first move. Okay, so this was your original game state. First chance is given to the minimum player, that is player 1, to make the first chance. Now he can put his particular X at 9 locations, right? See, these are all the possible game states that are there. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So these are all the things that he can do. He can make the x go on the first place. He can make the x go on the second place. He can make the x go on the third place, and so on and so forth, right? Now the next particular, in this particular tree itself, in this particular branch where we have put up where all the different things that player 1 can do when given the chance, all the different things that player 1 can do. Now after that it is a chance for player 2, right over here. Player 2, that is the Max, now has the chance. Now Max has this chance. If these are all the different moves that player 1 can put, these are all the different game states that player 1 has put up right over here, then now is the chance for player 2. The next chance will be given to player 2. If this is the chance that player 1 made, then out of this, now player 2 can put his 0 at 8 different locations. So this will create 8 different trees right over here, right? 8 different probabilities right over here. 1, 2, 3, 4, 5, 6, 7, 8, right? So that will create more probabilities, and we can map all the different moves, all the possible moves that player 1 and player 2 can take up. Are you guys able to understand it? Please let me know. Are you guys able to understand this, guys? Please do let me know. And this same thing is going to happen if this was the choice that player 1 made. If this was the choice that player 1 made, we will have 8 different outcomes from that as well. And this will go on up till the very end, where either of the 3 things is happening. Either player 1 is winning, either player 2 is winning, or there is a draw. So at some particular point of time, this tree-like structure that we are creating, for all the different moves of player 1 and player 2, at some particular point of time, the game is going to end. And at that point of time, our tree will end right over there. Now let us all forget whatever I have taught up till this point of time. Let's forget whatever we have been taught up till this particular point of time, guys. Everything, forget everything right over there. This was just an intuition about the game. Okay, just an intuition about the game. Now I'm going to I'm going to introduce you guys to a new game. Okay, I'm going to introduce you guys to a new game right now, completely new game. The name of the game that I have created is Undi, Bundy and Sunday. A, B and C, that is the name of the game, guys. Okay, a new game right over here. Undi, Bundy and Sunday. Okay, ABC, I'm going to call it as that. Now this game is something that I have created. You guys have never played this game in your life. This is a game that I have created myself. It has my rules. It has my regulations. I decide who is going to win. Okay. Or everything is going to be monitored and happening under me. Because I am the one who has created this game, right? So let's start by playing this game. This game is just like tic-tac-toe, in which there are 2 people who are going to play this game. Minimum and maximum. These are 2 players that are there who are going to play my game itself. The first chance that I'm going to give is to minimum. Because this is my game, I am deciding that the first chance that we are going to give is to the minimum itself. So minimum is given our first chance. Minimum does something right over there that produces 2 game states. Minimum has 2 particular things that he can do. Minimum has 2 particular steps. Like there are just 2 steps that he can do. Step A and step B. Just 2 things. So then there will be 2 game states, right? There will be 2 game states right over here. Again, once it has been the chance of minimum. Minimum has taken up the chance itself. The next chance will be given to maximum, right? The next chance will be given to maximum. Am I right or wrong, guys? Please let me know. If the first chance was given to maximum, minimum was able to do only 2 steps. He can either do A or he can do B. And we got 2 game states from right over there. Then the next chance will be of maximum. Now maximum in the first case can produce again 2 game states. Maximum in this particular, the second game state can produce 2 game states. Because this is my game, I am deciding that Max only has 2 options right now. Max only has 2 options right now in both the states. Then these are the different states that will be produced right over here, right? Then again it will be the chance of minimum. Again the next chance will be given to minimum itself. Am I right or wrong, guys? The next chance will be given to minimum, because right now maximum did his chance. So now minimum has this chance. Now again minimum, I am saying, because this is my game, the minimum has two possible steps that he can take, and as soon as he does that step, the game is ending right over there. The game is ending. As soon as minimum does any steps, the game ends. So these are the end states. Okay, let me just convert all of these into circles itself. Now we will be having minimum as the chance, and these are the end states, guys. So I'm representing the end states by a triangle right over here, that the game has ended. That the game has ended right over here. Right? So these are where the game ends. Now depending upon, so the game has ended. Now Max cannot have another chance. The game has ended. The game has been finalized right over here. These are all the different things that minimum and maximum can do to end the game. All the different steps that you guys can do. I've planned everything right over here on my board itself. So I can assign a particular value for every state of the board. Once the game ends, okay, once the game ends, I'm saying that there are three possible states that can be there. Either minimum wins, either maximum wins, or it's a draw. Okay, or it's a draw right over here, right? Are you guys able to understand this? Please let me know. Either minimum wins, either maximum wins, or it's a draw. So these are the only three things that can happen. Now we are programmers. We need to think about stuff mathematically itself. So if minimum wins, I'm assigning a value of -1. If minimum wins, that particular node of the tree will have the value of -1. If maximum wins, then it is going to have a value of 1. And if it is a draw, then the value is going to be 0. So minimum did one particular thing, okay, then maximum did one other thing, then the game ended. Minimum also did one thing, then the game ended right over there. The end state, these triangles that you are able to see are the end states, all the different possibilities of every single step that minimum and maximum are doing while playing the game itself, all the different states of the game that exist at the end. And the states can either be, is minimum winning, is the maximum winning, or draw. And that I've represented by -1, 1 and 0. So let us put those game numbers right over here, guys. It's just random numbers. Let's assume if this step is happening, minimum is winning. If this step is happening, it is a draw. If this step is happening, maximum is winning in both the cases. If this step is happening, minimum is winning in both the cases. And here it is both the draw. Here it is both the draw. For those guys who are joining us late and telling that they are not able to understand anything, you will not, because you are joining late. Okay, if you are here from the early on itself, please do not say that you are not able to understand anything. What are you not able to understand? Let me know, I will explain that to you guys. Okay, let me know, I will explain that to you guys. But just writing you are not able to understand anything is not helping anybody. You are also not able to understand, I am also not able to understand what you are not able to understand. And I am not going to repeat any shit. Because if you are not able to understand in the first manner itself how I explained it, just repeating that is not magically going to make you guys understand that. Okay? Good. The diagram with all the circles and triangles at the end, Vivek, that means you are joining in late. Okay? If you are joining in late, please do not put your questions. You are late in the class, you have already missed half the class, then how are you going to understand it? How Max gets 4 spaces. Okay, try to understand this, guys. This is a new game. This is a very new game, just revising it in one shot. Those who are not listening to me, they will not be able to understand. This is the min-max algorithm. I made a game, my own game. This is called as Undi, Bundy and Sunday. This is the name of the game, ABC. Now in this particular game, there are 2 players, min player and max player. There are 2 players in this game. Both the players are playing to win. It is not to make others lose. It is not to make sure that somebody else is winning. It is so that I am able to win. Both the players, both minimum player as well as maximum player. Now because this is my game, I am finalizing that this is the start of the game. This is where the game is actually starting right now. Okay, so minimum has two. So minimum is going to play the first particular like piece of the game itself. Minimum is going to do that, right? So when minimum is playing the game, he has two options. Either he can go with the decision A or he can go with decision B. There are just two options available to minimum. Let's assume first minimum plays A, then minimum plays B. So if minimum is playing the A route, if minimum is doing one particular set of moves, he has only two moves in this game. He has only two moves in this game right now. If he does the A move, then this is the new state of the game. This is the new state of the game. Let's assume this was the NT game itself. Minimum has two particular options. He can place an X right over here. He can place the X right over here. Okay. So if he places the X on the left, this is a new particular board. If he places the X on the right hand side, this is the other board itself. So I'm plotting down all the moves that minimum had. All the moves that minimum had, I'm plotting that down. Once minimum plays the game, once minimum makes a move, the next move is for maximum. The next move is for maximum itself. So right over here for this particular set of game, this is what the current state of board is. Board of the game itself. That is the current set that is currently having right over here. Maximum can put his 0 at two locations only. I have decided it because I am creating this game. My rules will be applied to this game. So maximum can either put, so the X is fixed right over here. Now maximum can put his 0 right over here, or he can put his 0 right over here. There are just two moves that maximum can make. Similar to that, here as well, he has just two moves. Here as well, there are just two moves itself. Now moving further, the next particular set of moves will be from minimum. The next, once maximum has done his move, then minimum has his chance. Again, minimum only has two set of particular moves itself. Two set of particular moves. Whatever minimum does, that ends the game right over there. Whatever minimum is doing, that will end the game right over there, guys. The game has ended. Everything has happened properly. Done. Okay. So the end state. So this triangles basically mentions that the game has ended. There's no more moves right over there. The game has ended right over there itself. And for every end state of the game, either minimum can win, either maximum can win, or it can be a draw, right? Either minimum can win or maximum can win, or it can be a draw itself, right guys? Please let me know. And that is what I mentioned with the numbers. For every triangle, I mentioned a number. If -1 is the number that you are able to see right over there, that means that minimum has 1. -1 basically retains that minimum has 1. Okay. If you are able to see 1 right over there, that means maximum has 1. Minimum has 1, that means -1. Maximum has 1, that is 1. And if it is draw, that is 0 right over there. Now you know the entire game, every particular step that anybody can take. Once you've created this tree, you know that any step that any player takes at any particular point of time in my game, I actually know it. If you already know that, then you can backtrack from it to figure out what is the best move for you. Okay, what is the best move for you? If you know this tree, if you know that, okay, if I do this, then this is what is going to happen next, then you can backtrack from it, choosing, okay, if I do this, then this is what is going to happen for me. I can backtrack from it. This is also called as a depth first search approach. Okay, a depth first search approach. We'll try to understand these technical terms at a later point of time. Right now, we just need to get a feel of the algorithm itself. How does the algorithm actually work? So all these technical terms, I'll be explaining it once again to you guys. Do not worry if you are not able to understand that. You don't need to understand it right now. Right now, we just need to understand how the game actually works. So now you have this tree. Okay. So first, as an AI, now you are an AI, guys. Okay. Now you are representing the AI right now. Let's assume maximum is the AI. Okay. Let's assume maximum is the AI, guys, and minimum is the human player. Okay, so from now you are the AI because you are programming the AI right now. So you are the AI and the person playing against you is the human. So now you need to think about how is the AI going to make sure that he is always going to win. That is the aim. Either I should win or the game should be draw. The person sitting next to me should never win right over there. Should never win. So right over here, guys, this is where the chance to minimum is given, right? Minimum is your human. Human is also playing to win, right? Human is also playing to win itself. So if two options are given in one particular place, minimum is winning. So -1 basically represents. If we are at this particular node, guys, if we were at this particular game state, please listen to me very carefully. If we were at this particular game state itself, in that particular case, which particular option will minimum choose the option A or will minimum choose the option B, guys? Could you guys let me know? Which option will minimum? Minimum is the human. Okay, minimum is the human, guys. Which option will the human select? Will he select A or will he select B, guys? Everybody is able to understand that the minimum is a human. Human is here to win. And because we as an AI cannot make sure that he's choosing, like, the human will never be choosing the B option. Never. Because he is there to win. So we need to make sure that as an AI, we are taking the worst case scenario and the best case scenario for ourselves. So for ourselves, that is the worst case scenario where the minimum is choosing -1. That is the A model, right? For us as an AI, that is the worst case scenario. We need to consider that. And for the human, that is the best case scenario. Human won right over there, right? Human won right over there itself. So what we will do is we are going to finalize that, okay, in this particular scenario, minimum, okay, minimum is going to choose this, that is the step A. So here the value would be -1. Well, because if this is the step that he's going to take, and we know that every single time he will be doing that itself. So at this particular node, if we are coming to this particular node itself, it will always be -1. If we are at this particular node, let us assume that we are not no longer on this node. So here we have already known that -1 will be the answer right over there. What about this particular node, guys? What will the particular minimum select? What will be the human select, guys? C or D? Okay, will human select C or will human select D, guys? Could you guys let me know? Will human select C or will human select D, guys? Please let me know. Right? The answer is any. He can select C as well. He can select D. In both the cases, no matter what he is choosing, he is losing itself. Right? Minimum, no matter what he is choosing, he is losing itself. Right? So here the value will be irrespective to anything 1. Right? The value irrespective of anything will always remain as 1 because he doesn't have an option. No matter what he chooses, he's going to lose. In the next particular case, guys, just like that, we are going to check up for every single particular position. For this case, guys, what should be the answer? Will the human select A or B? Again, because both of them are -1, we don't care. We don't care. The human does not care. Whatever he selects, he is going to win. So the answer will be -1 right over here. And for here, the answer will be 0. Okay, here the answer would be 0 at the end. Now it is the chance for maximum. Okay, we know that if we reach to this particular game state, this is going to be the answer. The final result is going to be -1. If we reach this particular game state, then the final result is going to be 1 always. We already know that. As an AI, we know that right now. So now it is our chance. We are the max, guys. Now the chance is given to us. If we are present right over here, will we select -1 or will we select 1? As an AI, I have to play according to the chances where either I am winning or I am drawing the game. I shouldn't let the other player win. Okay. So what will I select? Will I go with 1 or will I go with -1, guys? Of course, as an AI, because the choice is now up to me. The human cannot intervene right now. This is my choice. I'll be selecting 1, right? I will be selecting 1 right over here. And if this is the choice, if I'm here, guys, what will I select? Will I select -1 or 0, guys? Please let me know. As an AI, will I select -1 or 0, guys? Please let me know. Of course, I will be selecting 0 right over here because I don't want the other person. I don't want the human to win. I will try to make sure that the game is getting drawn right over there. And then at the start, again, the choice is given to the human. The human has no idea about this tree. The human has no idea about this tree. He's just trying to make sure that somehow he's able to win. So he doesn't know. He can choose 1 as well. He can choose the first path. He can choose the second path. He has no idea what he's going to choose right now because this is the very early stages of the game itself. So man, no matter what he chooses, no matter what he chooses, at the end of the day, it is either going to be a draw or the AI is going to win. Are you guys able to understand this? Please let me know. No matter what the particular human chooses, whatever minimum chooses, it does not matter right over there. Either the AI is going to win or it is going to be a draw. And this concept in which you first created the entire tree, okay, you first created the entire tree, you looked at all the end states of the game when the game gets ended, when the game, like, somebody wins, loses, or it's a draw, you first knew about everything, and from that particular point forward you backtrack all these steps to figure out which is the best step for you. This is called as the backtracking algorithm. This min-max algorithm is also referred to as a derivative, as a type of a backtracking algorithm, where you know everything that is going to happen inside of a game, and then you backtrack that. Then you backtrack that to figure out which is the possible best move to have to win this game itself. Okay, that is called as backtracking algorithm. The second particular thing is, here we have taken up the Undi Bundi Sandi game, the ABC game, which has somewhere around 8 different end states. Okay, the end states, the end games itself that are there, the triangles that are there, that is just 8. In an actual game of tic-tac-toe, these end states are more than 5,500. Are you guys able to understand this? Please let me know. For this Undi Bundi Sandi game, this is the reason why I was using this ABC example itself, because it's a very small example, very easy to understand, nothing too complicated about it, and we are able to draw it out properly as well. As a human, we are able to see this, right? There are just 8 end states right over here. In a game of tic-tac-toe, there are more than 5,500 end states that are there at the very end. So think about how large that tree is going to be. How large that tree is going to be, and keep that in mind. Here min and max only had 2 possible steps that you can take, either 1 or 2, just 2 possible steps that you can take at any particular point of time. In a game of tic-tac-toe, it is first 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So there are multiple things, that multiple branches of the tree that can be created. It's going to be a fucking large tree itself. So visualizing that, seeing that properly right over here is just impossible. That is the reason why we require code to do it. We need to code the entire shit from the start to the very end to be able to do that programmatically, because a human can't. And using this backtracking method, you can actually also play chess. If you have a very, very, very good GPU, you can actually play chess using the min-max algorithm as well. It's going to be very long, very drastic, because first you create the entire tree, then you go back to the entire tree itself to figure out what is the best move forward. So it is a very big code for a chessboard. Chessboard has more than 350,000 end states. 350,000 end states for a board of chess. And these are just the unique ones. There are multiple others as well, but these are just the unique ones itself. So of course that is a very, very huge board itself. We are not going to consider that. That if we are programming that, we'll go out of our minds itself. For our simplicity, we have taken up the min-max algorithm for the tic-tac-toe game. 2 players, not a lot of possibilities out there. Final things, 5,500. Any device can handle that. So that is what we are going to work upon in this particular bootcamp. Are you guys able to understand everything up till here? Any doubts or any questions? Do not say I'm not able to understand or something. Any doubts, any questions up till here? Something that you were not able to understand, just write it down in the live chat. I will try to make sure that some of the topics I'm able to cover. In the second minimum, why isn't -1 in the first circle? In the second minimum, why isn't -1 in the first circle? It's actually -1 itself. 1 minus. Second minimum, -1 is in the first circle. So it's -1 itself. I don't know what question was there. Any questions, guys? So, but we are making multiplayer without AI. We don't do this, right? But with AI, we have to use this algorithm. We are going to do both the things. We are going to create a multiplayer game as well, where you can play against your friend, and we are going to play a player versus computer game as well, where you are going to play against the AI. that you are going to create using this algorithm itself. So this is going to be the base about your AI. The AI that you are going to create, this is what is going to fuel that AI. And I want you guys to understand that. Okay. What does backtracking mean? So the backtracking basically means that you first created the entire tree. You saw all the game states that were there. Then you went back through the tree, making sure that okay, if this particular step is happening, then this is going to win. If this step is happening, then this is going to win. And slowly and steadily, that is how you formulate that okay, if your human is doing one step, what is the next best step for me to do that is going to increase my odds of winning? So this is called as backtracking, where you first create all the possible moves out there, you backtrack them, backtrack, you're tracking it in the backwards direction itself for every single move to figure out what is the best move for you guys. Okay, are you guys able to understand this? Please let me know. Hey, are you listening to me? Yesterday's attendance, please. Dark M Gaming. Okay, if you aren't interested in the class, please do fuck off from my class itself. As simple as that. You are not attending yesterday's class. You didn't even see what is the attendance or not. Just a 10 minutes class and you were not able to see that. And you are coming to this class, disturbing this class to understand if the attendance was taken up or not. All these students are there. They are learning something right over here. If you are not able to learn the class, please leave my class. It's as simple as that. I don't want students like you. I want students who are here to learn something. If you are not able to spend 10 minutes to see the previous day's class to understand if the attendance has been taken up or not, please don't come to the classes. You are just wasting your time. It would be better if you are able to watch some good animes or some Netflix shows or something. Lincoln Lawyer is one of the Netflix shows that I've recently started watching. I can definitely give it a recommendation itself. Otherwise as well, please don't come to the classes. I think so you're wasting your time right over here. Then why doesn't the AI always win? Because see, as at this particular question, just look at this particular question. The question is that why is the AI not winning every single time? The reason for that, it is not just AI who is playing the game. There is a human involved right over there. And the human is also playing to win. He is also playing to win right over there. We can make sure using an AI that the human is never able to win. It is either a draw or the AI is winning. But the human tendency is that I don't want to win, then I cannot win, then I will not let you win as well. That is the human tendency. So just take up the first step. If by mistake the human selects the first path, then it is guaranteed that AI is going to win. But if he selects the second particular path, then the AI is going to make sure that it is a draw. The AI is going to make sure of that. So because the complete reins of the game is not just in the hands of AI, it is also a secondary player who is playing to win right over there. That is the reason why. Okay. Backtracking is reverse engineering, right? You can think about it in such a way, but yeah, both of them are not correlated to each other, but yes, the principles are actually the same. Okay. Do we have to make the entire tree manually and then code it? Please, no. We are going to learn about something that is going to help us. We are not going to create the tree, guys. Do not worry about it. That does not work like that. The AI itself will be creating the tree. The AI itself will be doing everything. You don't have to do anything. Okay. We are going to use a particular thing that is called a recursion. Okay. We are not going to create everything on our own, guys. The AI will do it on their own. Okay, do not worry about it. How to implement this? That is what we are going to see tomorrow, right? That is what we are going to see tomorrow. How to implement the entire thing. That is what we are going to see tomorrow, guys. Tomorrow we are going to start our coding. So please be on time. Because tomorrow we will be starting with our coding, guys. We are going to code the entire hell out of it. Okay, because we are going to start from the utmost basics. We need to not just create the AI. We also need to create the game, the multiplayer game as well, right? So it is going to take us a very long period of time to actually do that. So make sure you guys are coming on in the class on time itself. Otherwise, you will be losing out. Okay, because we tomorrow immediately I will be starting out with the coding. Immediately as soon as you guys enter, I will be starting out with the coding itself. Because there's a lot to code right over there, a lot of things, because it's not just the AI that you're programming, it's the game as well. The board, the game states, people should be able to see. the two players who are going to play the game, they should be able to see that. There are going to be multiple things right over there, guys. Okay, so make sure you are coming to the class on time tomorrow, otherwise we'll not be able to understand it. Any other questions or queries that you guys are having, please let me know. Any other questions or queries, guys, that you are having, please let me know, guys. Is first box of max, then there is one. Why will AI choose to lose? Because his chance to move. Okay. What the fuck? In the first box of max, there is one. Then why will AI choose to lose? Because it's his chance to move. So right over here, the one is because the AI is making sure he is going in this particular direction. That is his chance, so he's choosing that. So this one is coming from this particular chance, this particular move that he took right over there. That is how it is going, right? Okay, like I said, guys, there is going to be multiple attendance in today's class. This is the very first attendance, guys, that we are having right now. Please start filling up the attendance right now. This is the first attendance, guys. We are going to have multiple attendance in today's class. The attendance link is going to close exactly in 5 minutes. That is by 9:02, the attendance link will be closed. By 9:02, the attendance link will be closed. This is the first attendance right over here, guys. The first attendance right over here. Okay, then we'll continue with the class. The class is not over. We'll continue with the class itself, guys. This is the first attendance for today's class. Please start filling up the attendance ASAP. The attendance link will be closed at exactly 9:02. That is in 5 minutes. Please start filling up your first attendance for today right now itself, guys. There will be 2 attendances in today's class. Please start filling up your attendance right now. I've provided the attendance right over here in the live chat. Then we'll continue with the class. This is the first attendance. There are going to be multiple attendance in today's class. AI will be having the option to choose min and max. Disha, what does that matter? How does that matter? AI can be min, AI can be max. Whatever he chooses, the human is also playing optimally, the AI is also playing optimally. That is you as a programmer who decides that, okay, I'm going to call AI as max, I'm going to call AI as min. It's up to you right over there. What would happen if it was AI versus AI? It will always be a draw. Both the AI will never let the other person win, so it will always be a draw. So somebody wins only if somebody else is making a mistake. Okay, somebody wins when somebody else is making a mistake. The human, because he does not know the entire tree, he has no idea which particular step to take to make sure that he is able to win. But the AI knows that, right? That is the reason why. So if two AI play against each other, it is always going to be a draw itself, guys. Okay. What is the relationship between code and algorithm? The relationship between code and algorithm are the same as a relationship between a driving manual, that is a book written on how to drive, and you driving it on your own. Okay, that's the basic difference. An algorithm is basically telling you how things will happen. What is the process for a particular thing to happen at any particular point of time. But a code basically makes sure that that process is actually getting implemented. Okay. Can we make the difficulty mode as well, please? There's no difficulty mode, right? The AI is going to take up one single shot itself if you are playing against the AI. Okay. So is BTech honors were to take, see, whatever you take, just prepare for your placement. That is all that I can say. Which app editor to use? So we are going to use Collab itself. We are directly going to use Collab itself, guys. We are not going to do anything else. Secretary, can you please show once again how did you assign 0, 1 and -1? Because that was my game. I created this game, Andi Bandi Sandi. So I decided that, okay, in this particular game, in this particular end state, maximum 1. So I'm going to assign 1 right over there. That is something that I did. Now in the original game, tic-tac-toe, that is going to happen on the basis of who wins in a particular game. So if max wins, that is 1. If minimum wins, that is -1. If nobody wins, that's a draw, that is 0. That is how it will be happening. We'll be making GLI or CLI. We are going to go with CLI itself. But it will still have the graphics, like you will still be able to interact with the game, you will be able to see the board state itself. Okay, everything will be game there, but we are going to use CLI itself. Okay. Is it mandatory that AI wins or it is a draw, or humans can also win? So currently in the game that we are having right over here, the chance of human to win is absolutely 0. Not next to zero, absolutely zero. Maybe in some other game where there are more possibilities that are there, some possibilities in which humans will always win, then that is a very different scenario. But in this particular game, that is tic-tac-toe, it is always going to be the AI that is going to win at all particular time itself. Okay. How are the games like Valorant made? They are very complicated. So there are AI. So for example, Valorant, I think so. Dota 2. How many of you guys know about Dota 2, guys? Please let me know. How many of you guys know about Dota 2, guys? Please let me know. Anybody knows about Dota 2? That's also a very famous game, I guess. Right? That is also a very famous game, I guess. If I'm not wrong, if I'm wrong, please let me know. Okay, that is also a very famous game. Like it has some world competitions and stuff that happens inside of Dota 2. So Dota 2 as a game itself has a particular AI that defeated all the 10 every single one of them 10 world champions of Dota 2. Think about Dota 2 as like cricket but video game cricket. Okay, just like GTA Vice City is there. It's like a strategic planning and attacking like Clash of Clans. Think about it as a very very good version of Clash of Clans itself. Okay, so Dota 2, the top 10 people in the entire world, top 10 people in the entire world were defeated 8 out of 10 times that they played against the AI. So there was an AI that was created that could play Dota 2. So we are working on very small games like tic-tac-toe and all these kind of games itself, right? These are very small games that are there. So there was an AI that was created to play Dota 2 and it defeated all the 10 world champions of Dota 2 8 out of 10 times right up there. 8 out of 10 times. So the point is that you can actually create AI that can play Valorant. You can create AI that can play multiple games. So I have created an AI when I was in college that could play the entire GTA Vice City. Like it could basically drive the car around properly inside of GTA Vice City. That's it. So it couldn't play the game properly, but like it could just drive the entire car around in the compound properly, following the rules and everything properly itself using like AI. So I've already done that. So these type of things you can actually tinker around with a lot of different people. Actually, that was something that I was inspired by Sendex. So Sendex is another YouTuber that is there, a very 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 great guy, man. So he created the entire thing. He actually taught the entire thing on YouTube. I learned it from right over there how to create AI that can actually play proper video games that you guys currently play. So what we are learning is a very 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 small scale thing of just like tic-tac-toe and all these kind of stuff. But yes, you guys can create AI that can play your Flappy Bird or Angry Bird. These type of games as well. You guys can create it. Okay, are you guys able to understand it? Please let me know. Sent Dex. So I will show you guys that YouTuber. It's a very very interesting person, guys. Definitely a person that I will wish that you guys are actually following. So Sentdesk, I think. Okay, I've written the absolute wrong spelling of it. Dex. So this is the person, guys. One of the best people out there to learn from. That is what I feel. I will show you guys his playlist that I followed for learning that. Let me see right over there if he has removed it or he still has it right over here. Oh yeah, this is it. So he created this entire video series of 25 videos where Python plays Grand Theft Auto. So he had created the entire thing of, it's a very good thing itself. You guys can definitely go through the entire thing, do the entire thing yourself as well. Amazing person. Just that when you're doing it, do not complain back to me that it is very hard. Without having the proper knowledge of that, you will not be able to follow this man. Like this man has created some amazing videos, but the point is that you need to have some basic knowledge for that as well. So he created these videos some 6 years ago, and that is what I'm showing you guys right over here. Some over the span of 2 years he created this, right? So, but yeah, an amazing person right over there, and it's great. Okay, guys, now that you guys have understood, okay, now that you guys have understood it, the project, are you guys able to understand Minimax algorithm? First of all, that is my basic question. Are you guys able to understand Minimax algorithm itself? Please let me know. Are you guys able to understand Minimax algorithm? Are you guys able to understand the term backtracking? Okay. Are you guys able to understand the term backtracking, guys? Now let's come to an important interview question right now. First, you guys need to understand what is BFS and DFS. Okay, these two terms. What are these? What are the meaning behind it? And why in this particular scenario? This is going to be a very important interview question when you present this project to your interviewer during your interviews for your internships or for your job positions itself. They are going to ask you a very simple question right over there. Why did you choose DFS? Why backtracking? Why DFS? Why not BFS itself? So that is what we are going to understand right now. Like I said, a very important interview question, guys. This is a question that will be asked to you guys 100% of the time. 100% of the time itself. So let's try to understand that, guys. First, we'll try to understand what is BFS and what is DFS. So this tree-like structure, the structure that you are able to see, right? This is called as a tree-like structure, a tree data structure itself, where data is being stored, but in a tree-like format. Now, each of these circles that you are able to see are called as nodes. Each of these circles that you are able to see are called as nodes, guys. I'm talking about some technical terms. These are something that you have to remember. You have to memorize. This is not something that I can make you guys understand. This is a structure in which the circles are called as nodes and these triangles are called as leaf nodes. End nodes, leaf nodes, that is where the tree gets terminated. The tree ends right over there. Okay, that is called as the leaf nodes. Okay, that is your triangles and your circles are nodes itself. Now there are multiple methods of going through a particular tree-like structure. Okay, now there are two type of trees that are there that you guys usually will be studying about in the future. Either it is just trees or it is a binary tree. Okay, BT. That's right, just BT itself. A binary tree means that every node can only have either 0, 1 or 2 child nodes. What do you mean by child node? Any node below this, any node directly coming out of this, that is called as a child node itself. So this is node. These are the child nodes. These are the child nodes for the above node. Okay. So a binary tree basically says that everything is binary. Either it can be 0, it can be 1 or it can be 2 nodes. That's it. You cannot have 3 nodes for one node. You cannot have 3 child nodes for one node itself. That is what a binary tree looks like. That is a rule. So basically a binary tree will look something like this. Always. So it will look something like this. Then you are having something like this. This is what a binary tree looks like, where you are able to see that every node only has either 0, 1 or 2 children itself. That's it. Now, a normal tree can have n number of children. It can have 30 children, 40 children, 180 children, 0 children. It is up to them. How many children they want to produce a children to the size of a particular nation. That is their capabilities. We are not asking about it. Where are these children coming from? That is their own lookout itself. You can have n number of children right over there. Now, for example, for our purpose, we were having the game, right? Tic-tac-toe. So the first step, no matter who is taking up the first step, whether Min or Max, he has 9 nodes right over there. 9 child nodes. You guys remember that? 9 child nodes that were there, guys. Right? So there were multiple things. So for our purpose, we are dealing with a tree. Okay, for our purpose, we are dealing with a tree itself. So we can take up an example of any kind of tree, right? Just like any tree, a binary tree, a normal tree. For right now, because we are not concerning about ourselves with any kind of structure itself. I'm just making some random tree right over here, guys. Okay, so this is a random tree that I've created. Okay, it's a random tree that I've created right over here. Now, to search for something, okay, you want to search for something right over there, guys. Something. You want to just understand something at some particular point of time. Inside of this tree, you want to search for something. What are the 2 methods to search for? What are the 2 methods to search for, guys? These are called as the first particular, let's see the methods itself. The first method is to see all the rows. First, we'll go to this row. Okay, we'll see all the nodes that are present in this row itself. The second particular method, then we go to this particular row. Then we go to this particular row itself. Then we go to this particular row itself. Are you guys able to understand this? Please let me know. We go row by row. Okay, we go row by row. One row at a time. We'll check all the nodes present in that particular row itself. That is called as your BFS or breadth first search. Okay. I have no idea what is the spelling. Breadth first search. That's the meaning of going row by row itself. Now, if you are playing a game, you want to figure out what particular step should I take. Let's leave that. Let us come back at a later point of time. The second particular method of going through the tree. Is depth first approach. Okay. First, I will be going into this particular direction. I will go to the end of the tree itself. Then I will go into this particular direction. I will go to the end of the tree. Again, I will come back. I will go to the end of the tree. So I will search according to the end nodes itself. First, I will check these nodes. These are the first nodes that I will check first. Okay, depth first search. First, I will go into the entire depth of it. Every single place where I can go to the very end of the tree first. That is called as depth first search. Then I will search for these particular nodes. These are the next nodes I will see. That is the next deepest node itself. Then I will see this particular node. Then I will see the last node itself. So I'm going depth first approach. I'm going to every single depth. I'm seeing all the nodes present at that depth and then coming out of it. Are you guys able to understand? This is called as the depth first search. Now, in that particular way, I'm able to see the entire tree. What is the end state of the tree first? I'm able to see the end state of the tree first. If you're going with the breadth first search approach, you are first seeing the first step, then the next step, then the next step, and then the last step. You're aiming to get to the very end of the tree at the very last. Now, when you're playing a game, guys, to make sure that the backtracking actually happens, why are you choosing backtracking? So I'm able to understand the entire tree first. Then I'm able to go back figuring out what is the best step for me. That is what we did inside of a game. We saw the entire tree, then we went back in the tree to figure out what is the best step for us. Now this is only possible in depth first search approach, where you get to the end of the tree itself and then we go back. We go to the end of the tree and then we go back. That is only possible in the depth first search approach. If you're doing a breadth first search approach, then you are only able to see the moves that you can do right now. That's it. You don't know which particular method is going to get you the best result forward, because you don't know the entire tree itself. Right? Are you guys able to understand why are we using depth first search approach? Are you guys able to understand why are we using depth first search approach, guys? Because we want to see the entire tree and then go back. That is only possible in depth first search approach. In breadth first search, we are only able to see what are the different things that I can do right now. That's it. I don't know if it is going to get me the result that I want or not. Because when breadth first search approach, if you are here, then you are only able to see these particular options or these particular options. That's it. You don't know what is the end state. Is it going to make me win or not? You have no idea about these states. Right now. So you cannot predict anything. You don't know the entire tree. What is going to happen in the game? And for our purpose, we need to win. So we need to predict everything that is going to happen in the game and then come back from that. Because we don't know the moves but know the results. Absolutely great, guys. Because we are choosing depth first search because we don't know the moves. Okay, let me just put it up once again. Because we don't know the moves but we know the results. So we can make sure which move should we take up. That's great, guys. Are you guys able to understand this? Please let me know. See, for a binary tree or for a tree with 90 different nodes as well, that is the same. The concept of BFS or DFS is not going to change. It's going to be the same, right? A binary tree is also a tree itself. It's not as if it's a separate thing. It has just one rule that is following. So no matter if it's a normal tree or a binary tree, depth first search and BFS is going to be the exact same, guys. That is not something that is going to change at any particular point of time. So tomorrow, guys, we are going to start with our programming. Okay, tomorrow, guys, we are going to start with our programming. So are you guys able to understand everything that you have learned in today's class? Are you guys able to understand everything that we have learned in today's class, guys? Please let me know. Any questions, any queries that you guys are having right now, please let me know, guys. Okay, so are you guys ready for tomorrow's class, right? Great. So please, guys, just one assignment I'm giving you guys for today's class. One assignment I'm giving to you guys for today's class, guys. Just revise the entire algorithm before coming to tomorrow's class, because when we are going to code the entire thing. I don't want anybody asking what is min, what is max, what is 0, what is 1. He should be able to understand that beforehand itself. Please just revise today's entire algorithm. Just try to write it down, try to understand it properly. In tomorrow's class, we're going to start the coding without any fail. Come to the class very early on, guys. Do not miss on the class, because please don't come back to me saying that I'm not able to understand. Today, many people joined us late and they were not able to understand the algorithm. In tomorrow's class, I cannot code one thing 2 times to make you guys understand it. Right? Please come to tomorrow's class early on, and we'll be continuing from right over there itself. There is no second attendance for today's class. Okay, we have taken up one attendance already. Attendance is done. It was taken up in the middle of the class itself. So for those who are coming late to the class, you are already late. I've already given you guys one warning. Still you are late, so there's nothing I can do about you. Come to the class on time, get your attendance, get your certificates. Okay, if you're not there in the class on time, I cannot help you guys with anything. So the attendance is done for today's class. You guys can leave as well. We'll be coming to the class tomorrow at the same time. So please be ready for that. Okay, the attendance is done, guys. We'll be coming to tomorrow's class at the same time. We'll be starting with our coding and we'll be continuing from right over there. Thank you so much, guys. We'll be meeting in tomorrow's class. Thank you, guys. Thank you. No, the attendance has already been done, guys. Thank you, guys. Thank you. Bye, guys. Bye. Bye. Good day, guys. Okay, so even I said bye and then I'm like, I'm still here because, yeah, my mouse isn't working. I don't know. Okay, yeah, it's working right now.